Good afternoon, everyone. Thank you for joining our webinar on outside-of-the-box applications with Omron's sensor portfolio. My name is Mike Hamoy. I am the Sensors and Precision Measurement Sensor Product Manager here at Omron Automation Americas. And with me is John Wensler, our Corporate Industry Development Manager for the food and commodities industry. Today, I want to briefly walk you through our sensing portfolio as it relates to food and commodities applications, breaking up our sensor lines into more manageable categories to make your product selection easier, and then take you through how our new products innovate in sensing distance, compactness, target generality, and data. As we tour our product portfolio, John and I will discuss different applications and problems we solve and how our solutions leverage the rest of Omron's portfolio to offer complete solutions to our customers. Omron has been in the non-contact sensor game since 1960, with the world's first non-contact switch. Since then, Omron has been expanding its product offering to meet the needs of customers across industries. With so many different kinds of sensors that include all the standard sensing modes and form factors, I'll break up our discussion into a focus on photoelectric sensors and fiber optic sensors, and then dive into our new proximity sensors. I find it helpful from a selection standpoint to split up our sensors into general application, color mark, bottle detection, and advanced functionality categories. In general application, we move from tiny photomicrosensors, which can be used for actuator detection, thumbnail type photoelectric sensors that can be used in machine to look at presence absence of mechanical internals, to more common barrel type and barrel mount sensors that can be used for basic part presence across the factory floor. These barrel mount sensors and their standard counterparts can be used in everyday conveyor applications like packaged goods counting, grouping and ungrouping, palletization initiation, or door obstruction presence absence. In addition to what are primarily plastic-bodied sensors, we also have metal body sensors that can be used in harsh washdown applications requiring IP69K rated sensors. From there, we have a variety of color mark detection sensors, which address both standard and very advanced color mark detection applications. These are useful for users looking to reliably and speedily recognize color marks for vertical form, fill, and seal machinery, as well as labeling machinery. As mentioned, our general application sensors have a variety of sensing modes. Some of them have bottle detection variants that retain the same form factor. But for more advanced bottle detection, we also have a specialized photo eye that can be used in applications where minimizing the pitch between the bottles or the clear objects being detected is required to maximize throughput. Finally, we have a new line of photoelectric sensors, which I typify as advanced functionality, that push the boundaries in terms of being product agnostic and do it with a compact body size at impressive distances. Let's take a quick minute to look at what we can do for color mark detection. Do me a favor and find the color mark. Let's see it again. At slower speed, it's probably pretty easy to pick out, but imagine this color mark on a glossy piece of packaging moving at high speed. It's not hard to imagine how that kind of mark could be missed. Marks like this are becoming more and more prevalent in consumer packaged goods and are difficult for standard color mark detectors to pick up. Our E3S DC can make this distinction with ease because comparatively, it has a much higher signal-to-noise ratio than the standard. Needed in a smaller space? We can tackle the same kind of color mark differentiation with our advanced color mark fiber amplifier as well. All these sensors use white light LEDs and interpret the red, green, blue content coming back from the color mark and its background. Next, John will take us through some applications where we've implemented our specialized bottle detection sensor, as well as our color mark sensors.
Thanks, Mike. Now in this application, the customer has multiple size bottles that need to be tracked. Normally, the user would mount the photosensor to shoot the beam between the necks of the bottles. And this works fine if all the bottles are the same size. But with multiple size bottles, the user is required to move the sensor and reflector each time a new bottle size is run. Well, that's no big deal, right? Well, if the line has 20 sensors and it takes a minute to move each one, that's 20 minutes. And of course, the sensors have to be moved back when going back to the original size. Now that's 40 minutes of lost production time per changeover. Well, now let's say that the line is running at 500 bottles a minute. Now that's 20,000 bottles lost due to changeover. That's a lot of lost production time just to change the sensors. Well, what's Omron's answer? Now we're going to use the E3S DB sensor, which provides a lot of benefits for this application. The narrow beam can operate in gaps as small as 3 millimeters. So we can permanently move the sensor to shoot between the gaps at the bottoms of the bottles. No need to move it. Now continuing with the features of the E3S DB photosensor, the sensor does employ something called p-opaquing. Now this double refraction attenuates 70% of reflections from things like transparent bottles. The result is faster reaction times, which allows the line to move faster. The beam is visible on the reflector. Now this makes positioning the reflector fast and easy. And finally, the E3S DB sensor is IP69 rated. It also employs auto-compensation control for contamination, so it can be used in the harshest washdown environments, like filling lines. We'll talk about different sized containers. How about different colored containers? We have a customer that needs to make sure the correct product goes into the correct container. The customer was making cola, diet cola, lemon, lime, and orange soda all on the same line. The trouble was, the people loading the empty cans had no real consistent way to know what soda was being filled at the time. So, needless to say, the people selling the product, specifically big box stores, got some pretty vocal complaints from their customers. Now, the difference in color between the cola can and the diet cola can were very slight. So we used the E3NX-CA sensor. Now it has two outputs that can trigger based upon the product it's sensing, and if the wrong can was coming down the line, it was blown off pneumatically before it reached the filler. But what about the other colors? Well, we could either use two sets of the E3NX sensor, or new settings can be sent to the sensor via the network from the controller. Now this reduces changeover time and waste. Now here we have a filling line application. Omron was requested to help find non-conforming products in the form of incorrectly filled bottles. The customer had increased the line speed, which resulted in many of these misfilled bottles. Now, as you may know, bottle filling lines are very fast, so any solution required sensors with extremely fast reaction time. So we chose the E9NC analog amplifier with fiber optic sensors to inspect the reaction time of the cylinder and the filling valve. So if the cylinder reacts too slow, that results in an overfill. If it reacts too fast, that creates an underfilled bottle. In these cases, a 1S servo system deflects the bottle for volumetric refilling. The result is no non-conforming product. Hey, back to you, Mike.
Thanks for taking us through those applications, John. What great examples of how these sensors can improve efficiency in setup and in part rejection. Now let's take a look at some of our newest sensors. The first of the E3AS series of photoelectric sensors is the E3AS-F, which is our first time-of-flight sensor. It uses a wide-angle IR laser light source to cut through the high moisture and vapor environments as well as dusty environments, and differentiates targets from their backgrounds based on time-of-flight technology. which essentially times the amount of time it takes for the light pulse to be emitted and received back. Since this is the basis for its detection, an object's color or reflectivity has little to no impact on the 1.5 meter sensing distance. To show how the wide spot and the time of flight technology of the E3AS-F work together, let's see if we can detect a metallic heat seal bag. No problem. But what if the bag gets deformed and could deflect light at all sorts of angles? This can present challenges for diffuse sensors, especially at longer distances with a smaller spot. With the E3AS-F, you can see that no matter how I manipulated the bag, we're able to detect the bag no matter what. Now, I'm from Chicago, and we love our pizza. But as I'm sure you know, not all pizza is created equal. Our most recently released E3AS-HL is a CMOS photoelectric sensor that can really help in really challenging applications like this one, where we're trying to detect a thin pizza dough on a moving conveyor. There are two issues here. One, we have to reliably detect that thin piece of pizza versus the conveyor behind it. And two, we have to deal with the roughness of the piece's surface or the unevenness of the surface. One of the options of the E3AS-HL is the line beam option, which we show here. For a small point laser, you would run into issues with the beam coming back at different angles that could cause chattering in the sensor output. The line beam addresses this because it allows us to quote-unquote average over a large surface area to provide that consistent output that you saw in the previous video. This is a significant advantage in a presence-absence sensor like the E3AS-HL, which is normally only found in precision measurement sensors. Let's take a look at another common application, bottle detection. Pay close attention. Did you catch that? Here, let's take a look again. Did you catch it now? One of the exciting capabilities of this sensor is that it can detect clear objects without a reflector. This limits alignment issues, issues with dirtied reflectors, and reduces setup time for these kinds of applications. For all our advanced sensors, we're also driving at ease of use. Take a look at how easy it is to teach the background here in this video. And notice what's going on with the display. We're using an OLED display so that you can clearly see what the detection value is and what the threshold setting is based on the teach point you just entered. Oh, and by the way, as we're changing that threshold value, we're actually changing it in millimeters. That's right. The display is actually showing detection value and threshold setting in millimeters. With this new line of E3AS sensors, we've shown just how versatile they are from objects that are shiny to clear to pizza, and how easy any one of them is to use. But how do they hold up in the environments you work in? Not only are these sensors laser welded to ensure they're IP69K rated and Ecolab certified, but they also have a specialized lens coating that helps repel surface contaminants. This coating protects the lens from buildup of oil, moisture, or whatever contaminant can foul up the sensor surface. As you see in these different examples, coated versus uncoated, there's no fouling around with a coated lens. In terms of environment, Omron is thinking of everything you might be up against, and it'll blow you away. In addition to the lens coating we saw on the previous slide, we've also designed this sensor attachment that can be mounted on any of your photo eyes that have mounting holes with a 1-inch pitch. take a look at how it can assist in keeping the lens surface clear of water or other debris by hooking up to a pneumatic line attachment. Let's move on to cover our proximity sensors. Whether you're new to Omron sensors or have just used one kind for a very long time, it's worth pointing out again that our sensor line is extremely expansive. We have a variety of plastic-based proximity sensors with ranges that expand out to 4x the standard sensing distance. We also move on to more specialized proximity sensors, ones that have metal face and body, proximity sensors that can withstand high heat and moisture, sensors that have chemical resistance, and others that have different form factors for all sorts of different applications. What I'd like to highlight is our newest sensors, the E2E Next and the E2EW. The E2E Next is our new flagship plastic face proximity sensor family, and is the family that boasts 4x sensing range versus standard proximity sensors. So what does that mean? It means that for applications that require a long sensing distance, you don't have to accommodate a big sensor like you used to. You can choose a 4x sensor and typically still be able to detect the object with a smaller size proximity sensor. In the E2EW metal face proximity sensor line, we've also incorporated this trend of extended range, but we also incorporate features like weld field immunity and factor 1 sensing. Factor 1 sensing is an interesting feature to point out because it allows the sensor to detect non-ferrous metals and ferrous metals at the same distance. So for example, aluminum and iron, respectively. In this next video, I'd like to show you how our new sensors handle aluminum. Obviously, aluminum is present in cans or bottles, but it may also be used in trays or other types of containers in conveyor applications as well. Notice what happens when I first set down the aluminum plates. Here we're out at 12 millimeters, the maximum sensing distance of our M18 E2EW, which I point out there. That's more than 2 times the standard M18 metal face sensor, and we're able to sense at 12 millimeters with iron or aluminum. What's also interesting to note is, remember how I talked about the extended range of the E2E Next? Well, this 4x E2E Next sensor senses iron at 9 millimeters. Although we can't sense at the same distance for aluminum, we can detect it at a longer range compared to standard plastic-based proximity sensors, because the overall sensing range has increased so much. As a final point about our sensors, we're continually releasing our sensor products with IO-Link. What is IO-Link? For those of you who don't know, IO-Link is an open network communications protocol that allows people to get more information from their sensor than just the output. It is the first sensor-level communications protocol that is adopted as an IEC standard and allows users to use standard cabling to accomplish sensor data collection and configuration. John's going to take us a little further on.
Thanks, Mike. Many of Omron's sensors support IO-Link. Now, IO-Link is an inexpensive network that transmits real-time data from the sensors to the controllers. So what can a sensor tell us? Well, it turns out a lot. How nice would it be for a sensor to tell you how it feels? Think of a proc switch that can tell you that it's nearing its end of life, or a photoelectric to tell you it's becoming contaminated and needs to be cleaned soon. Well, that's what IO-Link enabled sensors can do. The result is the minimization of unplanned downtimes. You can take care of sensor maintenance during normal, planned downtimes. No interruption in production. Oh, and by the way, it also tells you its own catalog numbers, so you have the correct unit ready when you're ready to replace it. Well, now let's look at an application that covers a larger group of products. In this application, the customer needs to track and trace serial numbers printed on those different colored cans that we saw in the earlier slides. Now, as you know, track and trace is a really important driver in the food and commodities industry. If recalls occur, it's vital that the manufacturer can quickly track down small batches. Now, if you're interested in more information on track and trace, we have an industry solution that discusses customer impact of recalls and Omron solutions. Contact your Omron or distributor sales engineer for more information on this solution. Now here we're going to use the E3S color mark sensor. Now this device can distinguish between very slight differences in color. So as the cans come down the line, we can use this sensor to trigger the FHV7 smart camera. This camera takes a picture of the serial number printed on the can, and if it's illegible, a downline diverter will kick the product out as non-conforming. Now the FHV7 transmits its data via EtherCAT to the NJ controller. And the E3S sensor, along with other IO-linked enabled sensors on the machine, well, they continuously inform the NJ of their health. The NJ can display all of this information in a user-friendly format to the HMIs, to industrial computers, and handheld devices. So what do I mean by user-friendly? Well, it's that different users require different views of that data. For example, machine operators, well, they want to know the machine health. Plant managers want to know about OEE and scrap rates. And C-level executives, well, they need consolidated production data from multiple lines and/or facilities. These screens are developed using Indusoft, an Omron partner with preferred connectivity to our controllers and devices. Now, the NJ controller has an SQL master on board, which also allows data to be consumed directly by MES and ERP systems. So as you can see, using the right sensor with the right features is essential when making decisions on machine control. The controllers, the HMIs, and the servos, well, they get a lot of attention. But it's the sensors, the devices closest to the product, that can make a huge difference in the performance of the machine.
If you're looking for more information, please visit our website at automation.omron.com.